Okay, now, just so everybody knows, Dr. Jan Thomas, he is being recorded. So everything you say, Ken will be.
Hey, when he leaves the room, we can all say what we really think.
No, it's recorded.
That's why we want to say what we think. Get the word out there, okay? Seriously, Lawton Public Schools for middle schools made a really nice, healthy purchase. And I don't know, what is it? Lance, how many lab quests did you buy from the school here?
36 each building, and it's on the sheet that they have right here.
Okay.
There's 12 per grade level, 12 for 6, 12 for 7 per grade. And they'll get 3 rolling cards, so each grade level has their 12 along with their associated programs.
So how would you estimate, are they shared 1 to 3 teachers, a set of 12, or 1 to 2?
The last time I looked, there are 2 grade level teachers in each building, so it'd be 1 set per 2 teachers.
Oh, so they only have to share with one other.
Right.
Plus our special ed teacher, but we all love her.
Okay.
Most of the buildings have a shared closet between the grade level rooms. Now, the deal with special ed is that most of them aren't grade level. They are having to teach across multiple grades. And so I'm assuming that they are having to share with all 3 grade levels. So like Bob Hughes would share, he may be using Irwin's one day and then in another hall the next because he can't haul them across the building all the way because the central's a mile wide. So that would be my anticipation. They're going to have to do it whatever fits best or works best for them. So
But they're going to be on the cards too.
Yes.
Takes much of a cart to hold 12 of those.
No, I think it's all the other ads.
Oh, the pros.
And I talked to Lance, I don't mind saying this, that's be his choice, but there are charging stations that are most convenient on a cart. So they have 4 of these things. And then you'll only have 3 charging stations full to hold 12 of these, and it's just, you know where they are, and they're all topped off with power. But that might happen. You might have to drown them up a little bit and get those charging stations. Show them that you're using them, that would convince them. Is that true? Huh?
I wouldn't listen.
Charging stations, he's talking about charging stations.
Yeah, we are looking into getting the price quotes for those now already, okay?
Whoa.
So you're saying you want us to rename our lab quest?
Yes. Okay, thank you for reminding me where I left off. And Lance has put little white tags, and it says LabQuest 2. Well, these are LabQuest 2s in green and red right there. But they also have a number. So the one I'm holding says 36A. So to rename it, if you tap the gear next to the name, this was mine, or LabQuest 2 Roger, tap the gear and then backspace out the LabQuest name and put in your number on the bottom of the LabQuest. So this one is 36A. So if you can't find that, raise your hand. Okay, look at these things that are showing up. Wow. You might want to delete the name LabQuest. It's kind of redundant. And just put in the number. At your school, if you have like 8 stations and you want to name them according to the lab tables or stations that the students are using, and that table always picks up the same LabQuest, not a bad idea. So
And you only got about 3 to 4 kids to get onto it.
that's true. You read my line. So some teachers even go to the trouble of saying, I'm going to number my temperature sensors with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so temperature sensor number 4 goes to table number 4 with LabQuest number 4. So yes, you know who's responsible, and then they may take better care. Okay, these are pretty rugged. They are water resistant. You cannot put them in the aquarium, but you can carry them in the rain. Okay, but you don't want to. If you drop them on the floor, it's like dropping your iPhone. And they do sell a rubber thing that goes on the outside to give it some protection like an iPhone. Most people that buy them say, we really don't want it. So that's your choice if you want them. They're not expensive. Also, my screen goes off like an iPhone to save power. So you can tap it, it comes back on again. Okay. So I can look up here and I'll refresh my screen, manually add, and if they're checked, I'm going to be able to see your LabQuest up here. So this is a classroom management tool. It's called LabQuest Viewer. And so you'll be able to see all 12 of them. Today we might have 24 LabQuests up there, and I'm not even sure. I've never tried to show 24. But we'll see what happens if you're logged on. So let's see, my screen is off a little bit here. So here's 36A. So I'm listening to myself and following my directions.
Yeah. Okay, I'm very sorry, because I should have said this before. You gotta know where the bathroom is, because if you track off out of here and try to go find a bathroom, you're not gonna walk a mile before you get one. If you walk right out this door and turn right, the first two doors are bathrooms. They're staff bathrooms.
And I went left yesterday.
But listen close. The first door is the women's bathroom. The second door is the men's. They don't say it. They're staff bathrooms. Okay? So anyway, but that's on purpose, because they don't want kids going in and out of them and all of that. Okay? So, but they don't say men or women's. If you're a woman and you're a lady or whatever, and you go in and there's a urinal, then you should leave, because if you lock the door, there's 100 men in this building that have a key. So, okay. All right.
Are they locked or they're open?
Right now they're unlocked. They're unlocked on purpose. Now there's the possibility that if a teacher from this building goes in there, they're going to lock it behind them because they don't want a kid in there. So anyway, we'll keep it unlocked again today. The janitors are going to try to keep it unlocked for us today.
Okay, great.
Okay? Sorry, I didn't mean to interrupt.
No, not at all. Thank you.
Actually, I'm glad you told us, because I was figuring I had to go all the way down by the library.
And by the way, if you needed something in this building, June right here was in this building for several years. She could probably tell you a little bit about it, and I'll be back. So I'm sorry.
Okay, so I'm going to refresh this list here. There's 36A. And if I tap that, there's 34A. Okay, since they bought 12 sets of lab, 12 sets, four sets of 12. Maybe they're A, B, C, D. I don't know how they were named. Whatever. You can always rename them. I would convince your students not to rename them. Okay? Because who knows what names they come up with.
They'll figure it out.
I know teachers that name them after scientists, but then the table has to say, all right, here's the Newton table, here's the Einstein, right, whatever. So you could do that. Numbers are plain and
I
simple.
can get it on your computer.
So, yeah. Oh, the software.
Right.
Yeah. Lance purchased a site license for his school district.
So how do we download it? Do they push it to us or?
I'm not sure. It's either on the CD or it's going to get pushed from the IT guy.
Okay.
Okay? You only need it on your classroom computer. It's a teacher classroom management software called LabQuest Viewer. Okay, so put that down that you want this for your classroom Apple computer.
That's only for Apple?
It's Apple and PCs. So right here I see 13A. It's not showing, so I hit the plus sign and check it off. LabQuest number 3. If you look on, who's got LabQuest number 3? If you want to just call it 3B or whatever it says, it doesn't matter. Who's got LabQuest number 3? Look on the bottom here, or wow, okay. Somebody's got it turned on because I'm seeing it, and it's been logged on to our network LPS staff.
Mine's probably not going to show. Will mine show up? I'm logged on to a different
No, you need
network. No, this wouldn't.
You need to get on to
It wouldn't
LPS
work
I've got, 5 on the bottom row and 4 on the top. That's 9 of them. We should get, I think, almost 15. We'll see what happens. Here's this one. Here's this one. About 33. Okay, we got most of you. I'm not going to slow down our training because the network signal like created in week something. So we've covered 2 things. How to log on. First one, how to put the lanyard on, how to log on. And it's important that your classroom computer is on the same Wi-Fi network as all of the LabQuest in your room. You do that once, it should be good to go. Okay? With this particular software, if there's one you don't want, you can just push this garbage can and take it off the screen. And I do know if you're side by side with another science classroom, you might see them. Okay? Your computer, if they're on the same network, they might pick those up. So you say, oh, I don't want room B, I just want room A. So if they show up, then turn them off. Once you get it set, off and running the first time, should be good to go. Okay? So put on the lanyards, log these things on, how to turn them on and off, okay? You should charge them, they should last for 6 hours. They're meant for a school day. Personally, I would have them on chargers when they're between classes to top them off, and then at lunchtime. And then when you leave for the day, they should just be on chargers. Nothing's worse than saying, okay, you have to use your LabQuest plugged in today rather than just in your hand. Okay? The batteries have about a 5-year shelf life. And they're not very expensive, but these LabQuest 2s are now entering the 5th year, and some people are having to replace the batteries, but that's the nature of a battery. So they're doing really quite well. So, any questions so far on just naming the LabQuest and getting them on the Wi-Fi, and then LabQuest viewer software? It's a really nice management tool. Personally, I like it because you can say, Table 3 is doing exceptional work. Want to click on it, show it off, and have the kids come up and tell the rest of the class what you're doing because you listen to me, right? These other people didn't hear.
And we could also use this as because we can make them bigger.
Yep.
Because, like if you have that class that no matter what you do, I mean, I did a lab with water and it was getting flung around the room.
Right.
So maybe instead do a demonstration in front of everybody.
Right.
Okay.
So here's mine, okay? And there's 2 things you can do here. So there's mine, and I'm going to go, I'm going to X out of the screen. It's like Windows, X out of a screen and turn it off, which is good. And it's going to go to my home screen. The home screen is up top left corner. It's the analog meter. It's a little, I'm experiencing about a 1.5 second time lag, right? And I click it, if I'm just using it, it's instantaneous, but because we're through the network. So when you first plug in a sensor, unplug my temperature sensor, it's not showing the temperature of the room. I plug it back in on the side, and the room is 22.3 degrees. So that's all it is. It's taking your sensor, plugging it in, and it gives you a readout. Pretty sweet. So we convert this thing into a thermometer. Okay. This device can also plug into a computer, okay, but with Wi-Fi you don't really have to connect it with the USB cable. But it's perhaps more secure if your Wi-Fi is not secure. If you plug it into USB, you're really good. If you're just using one and everybody else is watching. But this is LQ2 Roger, so it's the one I'm using today. And there's 2 ways I can go. I can go to my computer and touch anywhere on this red square. I can click on that and I get a drop-out menu. So meter setup or change units. You don't really have to put up. If I wanted different units, I could have Celsius, Fahrenheit, or Kelvin. most of us are gonna stay with our Celsius. Also, I can touch that red square on my LabQuest, and it's communicating and going that way. You can disable the fact that the student could be changing the screen in the Wi-Fi menu. Say, I don't want the LabQuest unit to have control over the one on my computer. Personally, train your kids and say, hey, I'm in charge right now, so I'm touching this, you're not. So I would give them the option, because they're at their station doing the lab, and say, okay, you don't have to come up to the board, like if it's a smart board. And if this were a smart board, this would be cool. Because you could just tap the red square. Do you have smart boards?
Does it work with the Vimeo?
You know, probably.
Okay.
There's nothing really special about this software. If it runs other software, it's going to run this software. I just don't know all the different school software programs. But I can't think of a better teaching scenario than having a smart board with this type of software for instructional purposes, and then the student can also manipulate it from his table and see what's going on up there. Ooh, a long way, baby. Really, really, really nice. Okay, any questions so far? It's plug and play. Put in your sensor, it comes up. Every sensor.
Roger?
Yes.
One more question. The LabQuest viewer sounds vital to a teacher. Do we not have that? We need to ask, man, is that correct, or?
He's purchased it.
Okay.
So it's now just a matter of if it's a DVD that you install it on your own computer, or it gets pushed out to your classroom from IT.
Thank you.
Every sensor comes in the bag with a little paper on it, the spec sheet. As a science educator who reads the spec sheet, you might even say, hey students, for the first time, I want you to know the limitations of this sensor. What's the maximum temperature it can read? What's the minimum? What's the resolution? Okay. What are some safety precautions? Can I put this in concentrated sulfuric? It tells you. Also, these spec sheets are on the Vernier.com website. So you can look up the probe and go through it, look for the specifications of the sensor. That's a nice learning curve. Kids have to know what the limitations are of any tool that you use. Very good. Okay. Before we go any further, first lab we're going to do is do some measurements of hand temperatures. Before I want to do any science at all, I want to know, well, what's the research question that you're trying to resolve? I don't want to be procedure-based. I want to be driven by the question. So, I've got a question. Is hand temperature gender specific? Are guys or girls as a gender one warmer or colder than the other? Anybody have any other questions you might ask about hand temperatures? Pardon? Is it dependent upon the length of your arm? That's a great follow-up question. I'm not going to do that yet. Measure your arm and then find out if it's proportional to the length of your arm. It's proportional to how tall you are. Another question.
How's it in body mass?
Is it proportional to body mass? That's a good question.
Right. I don't think none of us are gonna get on that.
Race.
What's another question?
I guess that's the narrative.
Race. Could be. Like this?
Yeah, it gives us class.
Age dependent, by the way. right now. Those are good questions.
You gotta understand.
Here's another one. Who's got the warmest and who's got the coldest hands in the room? And what's the range of temperatures of our hands?
You can't have more
Math,
than
did
that.
you help you math?
Right?
My hands are warm.
Good. Good prediction. Okay, good prediction. So,
Didn't work outside.
I'd like you to do this. Would you please on your agenda write down a researchable question regarding the temperature hands that appeals to you? One of those questions that we discussed or another one. So now, the new NGSS standards, did Oklahoma adopt the standards for NGSS? Good. So in those standards, and I know I've been at schools that say our state didn't adopt them, but they say, we just don't call them NGSS. We do the same thing. Anyway, the question comes first in science. Here's the big thing. We start with a question. I think we'll find students very much on task because they know why they're doing it. And secondly, I add one more thing to that. If I ask a question, I want you to put down what your prediction is of the outcome.
That gives them a hypothesis.
Right. Predicted outcome or hypothesis, or what do you think the answer is? So would you please, next to the question that you thought was a good question that you might be curious about, I want you to make the predicted outcome. To me, a predicted outcome is like going to the Kentucky Derby and buying a ticket on who you think the winning horse is. And if you don't buy the ticket, you don't watch the race really. You know, they're out there running now, but they win. If you do make a prediction, you put $10 on a certain horse, you're going to watch the race. Are you ready? We're going to start right now. And you've got a built-in temperature sensor, don't you? You can feel it. So I want you to do this. We're about evenly split between males and females. I want to have the females line up over here in the line, non-verbal communication. From the coldest hands to the hottest hands. And the guys, same thing over here. Coldest to hottest. Non-verbal communication. Ladies on my right. Guys over here. How you doing?
Okay. What do you think?
You can, this is a touchy feeling. You can't touch it. What did I, my estimate of an even split in population here. We only have 6 guys. But, you know, girls are smarter. They can handle it. They can handle it. You can do a double check right now. Last night to find out if you need to alter your position in the line. Are we good? Oh, okay. The guys are still. They need more time. They're only 6, but they need more time. So we got it, right? Before you sit down, okay? I want you to number off Alyssa, like in PE class.
1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Remember your number.
1, 2, 3, 4, 5, 6,
down what your temperature is, because you got that built-in temperature sensor. Is yours calibrated in Celsius or Fahrenheit?
Fahrenheit.
You got a built-in Fahrenheit temperature sensor? Okay. Put down what you think your temperature of your hand is, along with your position in line. Then, pick up a temperature sensor, plug it in, and make a measurement. I know what it is. Oh,
You gotta hand them out, right?
they're in the bin over here. Just pick one up. Not even on paper there. We'll reference that. I'm kind of alternative. Yeah. Oh, I like to go Celsius for science. Yeah, let's go Celsius for science.
Celsius?
Yes.
How many of us know our body temperature in Celsius? We're Americans. I know, I'm not, it is about 40, and that's all I worry about when I'm talking to my friends in other countries.
So, the temperature of the room is 22.9. At least in my corner of the room, it's 22.9. And I'm going to give a little more instructions, so if you give me your attention, please. Let me do a demo of how to do it. First of all, the thermistor is inside the stainless steel tip. Don't touch it yet. Okay, so right now it's monitoring the air temperature. Okay, don't touch it, because once you do it, it takes a while to come back to equilibrium of room temperature, although there's a nice way to bring it back to room temperature quickly. What would that be?
Unplug it. According to the instructions, it says put it in like room temperature water.
I hate students that read ahead of time with it. They know all the answers. Yeah, if you have some room temperature water in a cup that's been there overnight, and it's room temperature, you can put this into a liquid and it gets right back to that temperature really quickly. It's because water is much denser, about 1,000 times denser than the atmosphere, and so the molecules are really close. Everybody here knows kinetic molecular theory. So then when you dry it off with a paper towel, do it quickly with a chem wipe or paper towel. Don't just hold it down there, right? Get it dry. Is it important to dry it off?
Yes.
Otherwise you get evaporative cooling. You know, and so if you wave it around and it's wet, it's like coming out of the swimming pool and the wind's blowing. So we don't want that. We want a dry one. It's all set to go. It's monitoring right now. So this screen is monitoring the temperature of the room. This box over here is very important also. So if I touch with your smartboard, you tap here, it's like me touching you there. Hello. There. Oh, it's just a small delay. So this is for the resetting or changing the data collection parameters. So it's ready to go at 2 samples per second for 180 seconds. We could just leave it like that, but if you said I want a 1-minute lab, you would just tap right there. Oh, let's make it a 60-second experiment. So I'm just going to tap there. You can do this as well on your LabQuest. And now I'll type in 60 and say done. And then say OK. And now I'm doing a time-based mode for 2 samples per second for only 60 seconds. This is at the heart of doing digital data collection. Students should understand how long will this experiment take, and how much data do we need. More often than not, people oversample rather than undersample. I don't have to go 20 samples per second. I don't have to go 10 samples per second. Can you count to 10 in a second? 20 versus 19. All that data streaming in just makes your spreadsheet overcrowded. So one on the graph to see the pattern. 2 points make a straight line, right? A third point corrects it, and probably 5 or 10 points are generally pretty good on a graph. If it's changing rapidly, you might want 120. That's good. So, it's 22.5, and it's going to go there. Here's the collect button, and there's also a physical collect button right here on the LabQuest. It's the little triangle, the arrow. So more people seem to push the green arrow. That starts data collection. You're still listening, aren't you? So I'm going to start data collection. I want you to record initial conditions. There's the initial condition, which is room temperature, and then I'm putting it in my hand. So your graph is going to keep going, and it's going to go for some 60 seconds. So go ahead and give it a start. It's either the green arrow or the one on the, there's that one starts at 2. Just push that. If you put your temperature sensor in your hand first, you'll get the final temperature, but you won't know the initial temperature. So you want to be sure you do initial conditions, then you impose the change, like putting the sensor in your hand.
Because you have to move around to see if your temperature increases.
Oh, that's another good follow-up lab question.
If you concentrate hard enough to make the temperature increase.
Can you concentrate yourself warmer? Yeah, good research questions. So there it goes. I want to, as you're going, look up on the screen here. It didn't quite finish rising. So I could push the green collect button again. And here's a fun menu. It says, discard, append, cancel, or store. I want append. So I push the word append, and it's starting over. It's continuing. So I had a 60-second run, but it wasn't enough. Maybe I should have stayed with 180 seconds. But then I couldn't have shown you about that append option. And there's a blank in here. Well, it connected that dot to that dot. And it's going to go for another 60 seconds. Question? If you try to collect again, you know, with this sensor, it will ask on the bottom of the screen, it says, do you want to store it or append it, or cancel or save? Also, take note, here's the current readout, 27.5, and that's happening at second 152 to the run, minus the time that it wasn't collecting. So we have our temperature in time just talking to us. And when the arrow comes back, it was a red square when it's collecting, and now it's a green arrow. Means I'm done. So that's a 2-minute run. I'm taking the sensor out of my hand and I'll let it cool down, or I could put it in some water. Should I request it be room temperature when it comes out? on the table, maybe cooling back down? So I want you to get off your chairs, and I want you to line back up into your positions, the ladies from 1 to 17, the guys 1 to 6.
Okay.
And bring your temperature with you. The measured temperature, not your predicted. Know what your temperature is.
I started it just before I started. Cool it down. Just hold it down.
Which one? The 34 over here? Is it correct, the 34?
Okay.
Yeah, now I have
What did you have to direct us on cemetery? What are they thinking about?
What's your darn temperature? I just got mine started, so. My heart's working fast.
So the final.
We're about to sign 30.
What?
We're supposed to move this year.
That's like after a minute or two of testing.
No, you have to take a minute.
I'm still doing mine.
32 and here. I'm 31.3.
Oh, okay. All right.
330.
All right, this is.
Where are you, Terry? Come on.
Here, take this one.
Come on, you.
300.
Everybody in line?
Nope.
I think I was 33.4. Whoa, way down.
All right, are you in line from 1 to 6?
We need to do that
Good.
for original.
Original.
So I'm just gonna have you,
Let's see how
the original order. I think the girls are doing it, revising it according to low to high with the measured. If they do that, I like this. We're gonna see report the results two different ways. All right, hey, this is awesome. Are you ready? Okay, and are you guys in the original order, like 1 to 17?
No.
I mean,
We're by temperature now.
you're right, I love it. I never would have thought of doing it that way.
Sorry. We
So,
just figured we needed to move.
The beautiful girls here have lined up from low to high by measured temperature,
Yes.
not by
Not by
beauty, not by beauty temperature.
Mm-hmm.
So, here's the report. Okay? I know, number one nailed it. She's got the cold hand. You know,
The hot mama.
you're a world champion. You're a world champion.
All my friends make fun of me. I'm ridiculous.
All right.
And Jan stayed the hottest.
All right. So, to report on this, we should just number off, and it should be 1 through 17. Let's hear it.
1, 2, 4, 5, 6, 7, 8,
9.
10, 11, 12,
13. 16.
17.
Are you kidding me?
What are we supposed to
First group in the nation to.
Oh, you want us to say our
Oh, you
new
want me to give us
number,
our new number.
our old number, but in our new place. I got it.
Yes, I want your original number in
Oh,
your new place.
okay.
All right.
Original number, new place.
The original number. Listen.
Yeah.
Okay, 1, 2,
4,
5,
3, 6,
12,
10,
15.
8,
7,
9,
16,
11,
13.
17.
I have to take away the gold medal. But wait, okay, let's hear what the guys did. Are
We
you,
stayed in our original
you're in the
spot.
original number position, so would you report out your hand temperatures? And now we have to really process this. From the coldest,
Well, actually 34.9 for me.
34.9.
33.4.
Yeah.
26.2.
26.
That's my
Cold or
friend.
even?
303.
In Kelvin? Thank you. There's always a smart guy in the house.
30.
33.
31.5.
Close.
So it was the warmest to to the coldest.
Yes.
That's how we originally started.
No, cold to hot. Okay. Now, this verbal reporting is nice. Can anybody think of another way you might want to report out after doing this activity? With a graph? What kind of graph could you make?
Bar original placement
A
in a
bar
graph.
graph.
Line graph.
I think
Or
we should
real
line
graph.
Line graph.
Original placement
There's no
and-
change over time.
The bar graph.
The bar graph is for discrete data.
Okay.
You guys, your temperature is not really related to the one next door.
Exactly.
You're independent. It's discrete data, so a bar graph is nice, it's appropriate. And if everything ran like a perfect world, what would the shape, or how would you describe the bar graph? Anybody? Ascending, meaning,
Getting warmer as you.
anybody, what would it look like?
Stair steps.
Stair steps.
Yeah.
Stair steps constantly going up, maybe not always the same amount, but always going up. What software might make a nice bar graph?
Excel.
Excel makes a nice one. Logger Pro has a way to do bar graphs.
Students with paper and pencil.
Yeah, that's so 1950.
Yeah, but they're gonna have to be able to read graphs
Yes.
on
Yeah.
tests, so if they can't write a graph, they can't read a graph.
Make it a simple one like this,
Less
like
time.
just.
But it's
the
fun for
ticket
into
too.
Yeah.
computers now. They're
This is
gonna
a
be
great
able
way to
make
introduce one
money.
with Excel. With Logger Pro, which is Vernier's computer software, you can put the data in,
Right.
so like the first column is 1 to 17, and then in column B, the actual temperatures, and you can see them going on the screen with Logger Pro. And you have a site license for that. The site license is extensive. Every computer in your school, every computer at home for students and teachers. Okay? And the challenge is, of course, getting it installed there, but now Vernier has a way, if you know your registration number, you can give it to the kids, they go to the website and say, I'm at Lawton Middle School, whatever, and I have the right to download it and put it there. We're not gonna do much with Logger Pro today, so, but it's, I know Lance knows Logger Pro, so it's a nice way to do it, or Excel. I'm an advocate of Excel. It's universal, right? It's used in the business world, it's used in the science world, it's everywhere. So if there's anything that brought the analyzing community together, it would be Excel. It's not Intel TI calculators, it's not Logger Pro from Vernier, it's Excel.
They all have Google Classroom too, so if they're in Google Classroom and then Google Docs, the Excel part of that would allow them to build their graph and then share it through Google Classroom or Google Docs, however they wanted to.
Okay, I forgot this was a middle school, okay. Yeah.
Well, we're not, but we're getting there.
You're going that way. So the Google spreadsheet, okay, a nice way to go, and of course, don't have to download that, just be online. That's cool. I want to do one more thing, and then we're gonna give this one up and go to a really fun lab. You did your right hand, I didn't tell you? Did you do right, some did left? How about you do the other one? And my research question is, are your hand temperatures the same?
No.
So to do this, you store the first run, and you store it by tapping on the file cabinet. This will then go to run 2, and you won't see the red line. And it'll display run 2 on the graph. So your temperature sensor should be back to the temperature of the air in the room. Go do it. Store the first one and get room temperature, get initial conditions, and then start collecting.
The first run, I turned my duration way down to 6. That's why I got a compressor. I actually was showing how to change it to 60, right? So we made it 60, and then when we ran out of time, we just said collect again. You want a pen? If it's not enough, you can always get a pen. So you're good to go. Yeah.
Lisa, when did I go back there?
Okay, so I'm good, so.
I'm back on 10.
You were supposed to go to filing cabinet, see where I had filing cabinet and then
I think I did
two.
see it, because you got the app list of all those.
You're too far gone.
Especially one
Too far gone.
Too far gone for help, Dan, I'm sorry. There's no help for you.
Yeah. So it's, you do this and you can read it in a lot of time. And get a lot of analysis questions out of the way and the kids sit down and have it.
You can't back to the. Don't.
Hey, Roger, I assume that once they move beyond that, if they didn't hit the filing cabinet, they've lost their first bit of data.
When you, it'll say if you want to store or append or delete things.
So he got it.
If we
Bob
hit
got it back.
append, so.
This one right here.
Yeah, it gives you a heads up so you don't delete it.
There you go, now filing cabinet. Yep, he did it.
Or if you, when you start, remember where it said append? It also gave you the option to store. So the first you can either hit the filing cabinet or say, I want to store the run. So now, if you look at mine, I'm on run 2, and I'm done. And I'm gonna, just to continue, and there's this discard, append, cancel, or store. So I'm gonna store it, and now I'm into another run. So I'm in run 3. I'll show you how that was one of the, yeah.
She's not giving that screen, choice screen?
Because it seems like you could put one and two. Oh, cool.
Donna, could you stop wiggling up and down so much?
Mine's 25. Oh, my starting temperature was 25. My ending temperature.
Alright, I'm gonna look at it. And it's just, you just go through the chat. Oh, shit.
Okay. Hey, it's getting too quiet in here. My turn to talk. So if I touch where it says run 3, I just tapped run 3 and it shows me I did have 3 runs. And I could display all. So I'm going to touch all. There they are. So I have run 1, 2, 3. Okay? So that's pretty good. Alyssa asked me a question. She might have collected some runs that she didn't want. So Alyssa, you are number, I'm going to hit this array of 9 dots in the upper part here, and Alyssa, you're 36A? 35A, are you by chance with me here?
I should be. My Wi-Fi just connected.
35A, son of a gun. 35A. I'm looking for it. I don't.
How
Be
well
able to
do-
connect to 35A. I don't know what the deal is.
How well do these run on Chromebooks, or do they? Or is that a question for me to contact Vernier?
No. Yes. Yeah, they can be Wi-Fi or USB to Chromebooks.
Okay, well, what I meant was like for running this setup where they can see what the kids are doing. Okay, they could do it on their laptops.
Yes.
Okay.
Well, that was, but yeah, Chromebooks don't have any hardware or
Right.
software.
Okay.
But I can take this device to a student Chromebook. Alyssa, I can't see yours right now, so I'm just going to show it on mine.
What did you click to get it like that? My lab's still there.
Okay, there's mine. I have a run that I don't want, okay? So that third one that went down for a minute. So if I go across the screen, the upper left-hand corner was the meter mode. That's what comes up first when you launch LabQuest. The next screen is the graph mode, which comes up automatically when you start collecting data. It jumps to the graph mode. The third one over is XY. It's the data table. So it shows you all your data table, so temperature and time for the 3 runs. And so if I don't want run 3 for whatever reason, in the table drop-down menu, there's an option for delete run. Underneath it is clear all data. Let's just choose a run to delete. Oh, it wasn't stored. If it's grayed out, I hadn't stored run 3. So I'll show you how that works. So if I go back to the graph mode, hello, and the last one is stored by pushing the file cabinet. Now I can go back to the data table. Hello, and the table drop-down menu and delete a run. And I'll delete a run. And run 3 is being deleted now. Okay? So kids are going to do that. They're going to start it and stop it when they didn't need to, so you can show them how you can clean up your file. When you're storing a run, you have not saved the file. So all these runs are part of one major file, like you saw in the spreadsheet there. So let's look about how you might store a file. And there's about 3 ways to do that. So I'm going to go back to this mode. Hello. Okay. And if I do the file drop-down menu, why don't you follow with me on your LabQuest? So if you're on the main screen, and tap File, and this looks like, I don't know, Microsoft Office. You've got open a file, save a file, delete a file. Email and export are kind of unique to this. Print. You can print from your LabQuest to a Wi-Fi printer. Not all of them that are out there, but a lot of the HP printers. You can't have printers in your classroom. Well,
Not Wi-Fi on the net. So,
well, if you plug this into the USB cable to a computer that is connected to a printer, then you could print that way too. I know the world isn't printing on paper anymore, but where that is possible. So if you go to File Save, okay, and right now it's going to save it to the internal memory on this. It's probably what you don't want to do, because if period 1 comes in and they do Hot Hands Lab, and they save the file and say, this is P1, you know, Raj Larson's class or whatever it is, Hot Hands. Period 2 comes in and says, oh, I'm done. And I just opened their file and pulled it up. So better than saving it there is a USB slot right here. And you can use flash drives. I encourage flash drives. I mean, they're kind of old technology, but they're secure. You can email the files to an email address. It's a little time consuming only because this doesn't maintain a directory of all the email names that you may have used. And so
Can I ask you a question?
it takes a long, for me, at the end of a class period, to enter four email names might be take more time than I have.
Can they save stuff from here, like on our Chromebook, can they save it to the cloud under if they have a connection from this into the Chromebooks?
Yes, if you're running this on a Chromebook, then you are in the Chromebook world. So this graph shows up on the Chromebook, and then you have the little box with the up arrow and go to Google Docs or whatever. That's wonderful. That's 2017. Okay? So if you're displaying this data onto a tablet or a Chromebook, you're in that world. And you can see those files there. And that's, you know, the iCloud and OneCloud and all that, that's the new world. So I would discourage saving the files to the internal memory here. That's just me, because I don't want kids copying somebody else's data. If you do plug in a flash drive in here, you go that route, it will show you the flash drive pitchfork, and you tap that pitchfork thing, and then the file will go to the flash drive. So those are some options for saving. So let's just recap. What's been covered so far regarding data collection? Just one thing that you now know that you didn't know at 8 o'clock this morning. Anybody, raise your hand.
Run the data and save it in the filing cabinet and do a second run.
Good.
How to log on to it?
Very good. How to get your password. Somebody else? What else do you now know?
If you've made a mistake, you can delete it or run.
Delete a run is cool. Yeah, you know where to go for that. Yes.
Actually, I was gonna ask, can we use this without going on Wi-Fi?
Yes.
Okay.
Yeah. So as a standalone in the classroom, nobody else can see what you're doing, then you don't use LabQuest Viewer. Yep.
I mean, because I know our Wi-Fi sometimes says, what, I don't exist. So, yeah, so if we can, you know, we got used to walking around and checking to see if the kids are doing what we're supposed to.
Hey, one good thing is, you could be on Wi-Fi here, but you're not on the internet. The kids can't go surfing on this device, they gotta get their cell phone on the service. So this is just to run this application. Anything else, we're just kind of reviewing? Yes,
How
please?
to organize them, how to name them and label stuff.
Classroom organization, fantastic. Very important.
Are these ports turned off or something? I'll put a flash drive in, it's not recognizing. That could be what?
Push it in all the way. And then when you do file save, you should see the little flash drive icon. I've known some flash drives that somehow it's a function of the flash drive. I pull out another one and it gets red. It's really not a function of that port. I doubt. Very much doubt that. Try a different flash drive. We haven't discussed how to turn it off. Okay? The screen does go black after a certain period of time. And the power button's up on top. It's recessed, so you don't actually push it. Okay? And if you just tap it, like
it says, you have unset data, do you wish to discard the data? And I'm gonna say, oh, I have to discard, cancel, or save. If you hold this down, because it's got the data in there, it hasn't been saved, I get that. You tap it, it should put it to sleep. If you hold the power down for like 8 seconds, it'll turn it off. It's like an iPhone. The other thing that's important to do if you're starting a new experiment is to do File, New. So if you do a new one, I would remove this temperature sensor. This is auto ID. If you put a sensor in, it automatically recognizes it. It may not be auto forget. Okay? I think it's been requested to put that in the software, but I am in the habit of saying, do a file new, remove the sensor, and then do a file new. And it's going to say discard, cancel, or save.
Yeah.
Well, I'm not going to save my data. If you want to save yours, put a flash drive in. I'm going to discard. So then I'm ready to do another lab with a different sensor. Okay? So I'm only saying that if you did a temperature sensor lab, remove the temperature sensor, then put in a 4 sensor, the system thinks there's still one in there. So just do a file name. Okay. Yeah, we're gonna.
Okay. Real quickly, while he is on the transition, what I'm gonna ask you guys to do, there are a couple of things that came up this morning that I think we would want to add in the future. One was if we're gonna use Logger Pro or anything like that, that would be a future professional development, so I've written that up here. One of the things that was discussed this morning was if you would like to have or need charging stations, which I think is a good thing. I've already started that process, but I wrote that up here also. So if there are things that come from this that we need, that you want, then if you'll put that up here, then I'll look into getting that. And I know that April the 9th is the next training that we have scheduled, and some of this we can try to work into that date. But there's parts of it that we may just want to have Roger come back and do. But anyway, so that's what I had.
Thank you. You don't often get that support. So flooding what's requested stuff that you think you need. But I said, Lance, let's get them using the stuff that we've got here. We've got a great collection.
April 9th?
It's a Saturday.
It's Sunday.
That is April the 8th. Last year must have been April the 9th.
Okay, do we need a 3-minute potty break? Want to take 3 minutes for that? Okay, at least stand up, move your knees, and I'll see you in just 3 quick minutes if you want to go down the hall to that restroom. All girls go in one.
There's also a restroom, if you go straight down the hallway into the attendant's office, there's a staff bathroom in there. They're seamless, but that would help you split it up.
There's a student restroom, you make a left down in this hallway, the student restroom.
I wouldn't go to the student restroom, it's gonna be cram-packed full of kids in about 7 minutes.
Well, yeah, if they went now.
Okay, so there's something, so are we using this for today?
Yeah.
So we'll use this again? Okay.
Good, I'm trying to get over, like everyone else, I think the whole district's been sick. How are you doing?
Did I hear you say that the youngest is youth minister?
Whoa. Oh my God. you have your computer stuff.
But I did.
So I used to do, I used to have the kids make wheels out of wood, stuff like that, stuff like
It's pretty much that way.
These lovely
Yes, so I'll show you
In
this.
fact, I think I need a list of all of them that need Work is carried.
these too. Okay, we've got a couple of people missing, I'm going to start this real quickly. I've been asked the question a couple of times, and I know that we have new teachers in and out and that sort of thing, so one of the things has been about textbooks. We have come together, we've had teachers look at textbooks, we've vetted some resources, and when we came down to it, the Broken Arrow open education resources are the ones that, gotta get my words right, we didn't adopt because you can't adopt them, but they're selected as our classroom resources. So the way to get to those is you go to our website, go to menu. You can go to, there's a couple of ways to get to them. You can go to departments and curriculum and all that. What I do is I just go to documents because I remember what they are. Under documents, you go to departments, curriculum, science, OERs, which are the textbooks. And then these are the textbooks that we have selected as a district for science from teachers. Our teachers looked at these textbooks and said, we're going to use these in our classroom. So there's everything from AP Physics, Biology, Physical Science, and then there's 6th, 7th, and 8th grade OER. So if you look at these would be the location for that. Now, if you click on it, it's going to download the whole thing. Okay, that's just the way our website works. I don't understand it, I don't agree with it, but that's the way it is. That's why I'm not clicking on it on Roger's computer, because I don't want it to just download the whole file. But anyway, this is where those PDF documents are. Your kids can get to it at home, your parents can get to it at home, you can use them. There's links inside of this that go to videos and that sort of thing in each of the lessons. But anyway, that's where our OERs are for science. We've put that out several times. It's been in our newsletter. But anyway, I was actually asked again, so that's where they're at. Yes.
I was looking at them yesterday, and this is probably a technology thing, I don't know the answer. Is there any way, like, for in classroom, for me to just take out those pages and input them, or do I have to do the whole book again?
You should be able to do sections or pieces of that. Send me that in an email, and then what I may do is we'll look at maybe uploading it in a different format.
There is
Okay.
a thing you can
It's
purchase
in
for
Google.
parents, they can PDF to a Word doc, but you have to take them out and then
Well, but here's these are in PDF form, and they're all made and saved in Google Drive. So this is how we've uploaded them. We may be able to share them in another way, and that will have to look into that. So send me the email, and we'll work on how to do that. Okay? I need to get off of this and let Roger get back to it. The other thing I was going to tell you is back on what you need. There's no question in my mind that the labs that we selected, that were selected last year, there are labs that are inappropriate for grade level OAS right now. Okay? There's no doubt about that in my mind. When you look at them, there's some of them that don't work. That being said, if you go back and you say, we really want these 3 labs, but we don't have the probe we need for that, then if you'll, I don't want that down here today, because you may know that, okay? But if you go back and there are probes that you need to make your grade level work, that you want these 2 labs added to your list, then I need to know that so that we can work through it. That way I can identify those and get those purchased. But I know, I want to say it was, I want to say 7th grade was fairly well aligned. I can't remember which one. I'm going to speak out of turn.
I remember.
But
You said 6, wasn't it?
was not, okay, maybe it was 6th grade. It was not aligned very well. But anyway, we'll look at it. You guys, there's no sense in doing a lab if it's not aligned to your standards, right? So keep that in mind, and we need to look at that and readdress it. So if there are labs you need to do or want to add, and there are probes that you need to make that work that you do not have currently, then I need that in an email form, and we'll work on making that purchase, okay?
I can see your kids doing this lab every year from now on, because it's a great way to introduce them to the probes.
Okay, sorry.
Okay, before I forget, Melissa gave out the blue cards early on when you came in. Did everybody get one? We can fill that out now. And then I'm not going to kick myself at 3 o'clock when that filled out. But print clearly, please. The purpose of the card is to put yourself on the Vernier mailing list. We've got 2 wonderful emails a year with the newsletter. And the newsletter contains innovative ideas from other science educators nationwide, worldwide actually, on new uses that they've thought of for different sensors that they purchased. So it's sharing ideas, and it also discusses new products that are out there and tells you about updates and things that are going on in the Vernier world. So nice to be on that. And they won't sell your email address to anybody, I promise. I know that's true. So what's important here is your name that's legible and your email address. I don't really need the address of the school. So Lance is your primary contact. He knows Gary Myers real well, right? He's the guy you worked with for the purchase, maybe. And any comments that you want to make? Some people put evaluation type comments there or other requests. The bottom there of what you teach, if you just say science supervisor, science or whatever, it's not that important. And the biannual newsletter, say yes to that. A yearly catalog. The catalog is online. I don't know if you want a paper catalog or not. So, and then about updates, that's optional because the updates get into the newsletter.
And before you do the next lab, I would greatly appreciate the next lab. There's going to be ice and water and all that, so I would appreciate if your computers do go up because I don't want the media department mad at me because we ruined a computer or two today. So, anyways, that's
yeah. Let's put the school computers over there on the side. Maybe plug them in.
yeah. There's plenty of room over there to plug them in. Okay.
Yes. Keep your temperature sensors. In fact, if there's a second one and you have two, the next lab we can use two sensors.
When these are filled out, we can leave them with you, or?
So your blue cards, when they're finished, they can come right up here, make a stack.
And then what is that? Work files over there? The book online is what it is? Buy and read one. drop your computer for a week and you go.
It's like the kids, is anybody not gonna put learning fill out? Short one.
Yeah, go in the backyard and get my
All right, we're regrouping. Oh, yeah. Short science. All right, here we go. Are you ready?
Yes, sir. Let's do this.
Right. Thank you very much. Okay. We need to start, have a reason for doing the next lab. The question comes first. If I don't do that, you're not following your own advice. Okay, and I'm not even going to get the paper out of the Vernier book for this one. It's wintertime in the rest of the country, but not here in Lawton. I saw it's going to be up to 90 degrees Saturday.
Yeah. Really? All the way up there? Going out swimming.
That's what my iPhone weather app said. So I'm flying back to Boulder, Colorado, and we can still go skiing. You know, we're
88, yeah.
88. I don't believe it. Anyway, the people in the ski resorts won't like that because it'll be 88 degrees in February out there.
And we've got moths already.
Oh my goodness. Okay. However, so it may not be a local issue, but Lance told me that this weather was really up and down. We're on the cusp for something out of Texas or whatever it is, versus what you might get fresh air from Colorado. But it does get cold here. And sometimes it gets icy out there. And slippery.
Activity started. Activity stopped.
I was trying to clear it. Sorry.
That's okay. So I know some of the big stores, Lowe's or Home Depot or whatever, sometimes say you can buy this salt ice. And you can put it on the steps of the school so the kids don't fall and hurt themselves. And you don't get sued because you did put the salt out there and you didn't know how to stand up. So here's my question from the science point of view. And this is for you to think about individually. What happens to the temperature of the ice when you put salt on it? Think about it. I want you to write down what you think, your little prediction, what happens to the temperature of the ice when you put salt on it.
Can I use my phone?
No, don't ask Google. Ask yourself. Just yourself. Just yourself. What happens? And then secondly, if you went qualitative on that and you said, I think it got warmer because it melted the ice, or it got colder because, I don't know. And then I want you to make a little prediction, how much? So go quantitative. I think that if I put a lot of salt on the ice, it would change the temperature this much. Or how much could I possibly, what's the maximum amount I could change the temperature? Is it exothermic or endothermic? What is it when you put sodium chloride on ice? We know that ice is probably at least 32 degrees, right? Fahrenheit or 0 Celsius. your predicted outcome with the person next to you. Thank you.
That's a lot of work, and I know they have the appearance. No, milk's in the middle. Milk, you just put salt. Yeah, it's just salt. Oh, around it, and it has to keep that side of that cold. I'm so
Somebody else who watched it.
See, that's what, Dan, I was asking that question to Dan, because when I do homemade ice cream, which they don't make.
Yeah, I didn't when I made this, my
I know, so you put that on there, you can.
Yeah, we make it cold, and the more you put on it.
Right, I know, so I know it's.
Yeah, but on the road, you also put sand.
Yeah.
So you actually sand or all.
So when, so even though it's melted,
But the sand, stays soft, and it's crushed solid salt. You don't put rock salt on the road. You put sand, you would put really thin sand. That's gonna displace the wind. They don't put real thick, they put really fine sand. So, but you put sand on it. I don't know. I wonder if you measure, I wonder if you took table salt and rock salt and measured it with the temperature.
All right, here we go. Hey, we got a range of ideas going on here. And no, you can't Google it, because then you're just gonna talk to somebody else that they did it, right? And they're not better than you, okay? So we just have to collect the data and have a real good look at it. And here's what to do. We're gonna make a little calorimeter, simple calorimeter going. It's styrofoam cup with a beaker. I'd like you to put chipped ice over there, fill this thing about 2/3 full of chipped ice. And then I want you to add water, but just below the top of the ice level. It will melt, and I want really concentrated ice water. Okay? Just like all those fast food places that give you more ice than Coke. Cheap. Anyway, and chipped ice is good. If it snowed here someday, snow's probably the best, just because it's a slush. we had a slush in here, ideal. Procedure, okay? Oh, yes. Well, maybe we'll do that on the next one here for starters here. So you can have slush ice, and then I want you to do a data collection, and let's give ourselves 5 minutes for this data collection. So change it to like 300 seconds. 2 samples per second is fine. But just change the duration from 180 to 300. And initial condition of room temperature is nice to have. Then I want you to put your temperature sensor in there and find out what the temperature of the slush. You probably have a pretty good idea what that temperature is going to be. Stir it around to get a good average. And once you've reached equilibrium for the temperature of the slush, you can add up to, you can do it incrementally, but up to about 5 heaping teaspoons of salt. So we have these Morton's sodium chloride there. We can, let's put one on every table. And there's plastic spoons over there next to the ice. And if you want to modify that procedure a little bit, but on your graph, I'd like to see room temperature for a little bit of time, the slush temperature for a while, and then keep going and stir as you add. Okay? Is it going to get hotter or colder? And I've heard both options. And how much? Nobody really, we have some good guesses. That's about it. Okay? You can work in teams of 2 if you'd like. Okay? Go do it. We're going to have about 10 minutes for this. By the way, I'm looking for the group that gets the largest change. Who's going to get the largest change?
Grab 2 of those. You got it, Barbara?
No, we need one.
Curtis, we're good. Curtis, are you getting something? I'm getting some.
Yeah. It's not critical. Yeah. No. We're going to add the salt after we get the temperature of the salt.
All right, I've got our sample, sir.
I need to know the initial condition to find out what adding salt. Is everybody clear on the procedure?
No. Yeah.
We want to have the temperature air and the temperature of the slush before you add ice, and then the temperature of the slush before you add salt, and then keep monitoring a timing study as you add more salt. Hey, I forgot to do one thing. Just give me 5 seconds, please. Ready?
Ready.
Stand up if you think it's going to get warmer. And if you think it's going to get colder, sit down. It's going to get. Stand up if it's going to get warmer. Wasn't that you guys over there?
I initially said that, yes.
You thought warmer,
I
okay?
initially said that.
And why did you say that?
Basically because, my logic was that the temperature is going to decrease by a point so that it will thaw, the ice will thaw.
So So is it gonna be older or higher?
In this case, it's gonna get cold. Temperature down.
We had a difference of opinion, and I thought you said it was gonna.
Yeah, I said it was gonna get, I said it was gonna increase.
Increase.
Right.
And everybody else,
Yeah, everybody else was saying it's gonna come up.
and how about this one here? Hotter, colder, stay the same? Colder?
It's 0 degrees.
All right, that's all, I just wanted to know what you thought.
You think hotter, colder, same?
I think so. Because I have this whole ice cream theory, because I make it and they don't make it. How do you, I was like, don't you know?
So you know hotter. No.
Now, if we're gonna add the salt, we just keep this going, and then add the salt.
Yeah, once is your graph there, does it reach equilibrium? And you may have to do a pen, keep a pen there, okay, just didn't go to 5 minutes, 3 seconds, the whole thing, just keep, it just depends on it. So, yeah, keep it going and keep stirring.
The 300 seconds includes the salt too, right?
Yeah.
Okay, yeah, we got it here.
Yeah, a big heat, and stir, 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 stir.
Go ahead.
Yeah, stir, stir, stir. Stir.
So we're gonna go ahead and.
Yeah, keep stirring. Up to 5 teaspoons of salt and stir, stir, stir.
No.
Okay, you're
Plus, when I do my test, I let set up the deal with
And I've done this because I do goldfish.
put them in regular water, count the respiration, then we give it like 1 ice cube of water in there, and count the respiration, then we do it up to about 5 ice cubes. First it's too low, because I get that shock of cold, then tell it, if they die halfway. But yeah, it's but I don't let the kids do it, but I get to the point where I put like fish frozen in bed, and they're like, oh, they're dead, but I don't want my teacher, and then I put them in bed and start to swim around, and they're like, are they dead? You expect why? And then I have to let them know that they're fine. Forget the goldfish that morning. And I keep going the next morning, they're all dead. And they're only like 15 cents over. So I use them to buy in the morning. At least part of it. You're so funny. Perfect. I had to. And they always went to the computer. Of course, I don't want to do that. Okay. That's what happens to go. It's a very okay, so now that I need I didn't know that's how you could tell. like you said, it's sand negative, so I think it's sand neutralizes it.
And who,
Or
who is this that wants
makes
to
it, then it can go.
What did you say the sand makes heat? What'd you say?
Phase change.
Okay.
Same reason why you get cooler when you split your halfway through.
Okay.
Still keeps on getting colder.
But would it matter if it's rock salt or
I don't know,
regular salt?
I would like to see that.
Many cycles or
I would like to see. I would like to see.
She is adding some salt now.
We're supposed to add tablespoons to there. We're still dropping.
Yeah.
whatever we put salt in.
Maybe this has also small.
And then the next one starts to go down. No, and then if you put like normal salt, then basically it's and then we turn the little fish tank that has one water.
Hey, are we done with our 500-second lab? All right, listen up. I've been able to. Okay. All right, listen up here. Great discussions going on among the groups. Okay? I think we all know the answer, don't we?
Yes.
Yes.
Let's just report out how much. So, per group, tell me how cold did it go? Okay? What's your answer?
-12.
-12 units, please.
Celsius.
-12 degrees Celsius. Yours?
-9.1.
-9. Over here? Let's listen, please. I want you to compare what you hear to what the others have heard. How much again? Okay.
11.2 degrees Celsius. No, negative 11.2 degrees Celsius.
Perfect. Nice.
Negative 13.6 degrees.
Winner. -13. Yeah?
Negative 14.9 degrees Celsius.
Double winner. Yeah.
Negative 13.6 degrees Celsius.
Wow. To me, anybody below colder than -12 is a winner. Yeah, what do you?
-12.
Unbelievable. Okay? So now we know what does happen. We didn't have to Google it. Can anybody explain it?
The sodium chloride causes the freezing temperature of water to be reduced. So therefore, since it now needs to have a lower temperature to reduce, it can melt.
And it's a tough concept. are. Anybody ever study that in a college chem course?
I did in high school.
High school? Do you know what the name of that lab was all about? It's a different value for sodium chloride or potassium chloride or mag chloride. Anybody remember that thing? There's a table in the back of your chemistry book all about that. Anybody know? Yeah?
Freezing point depression.
Freezing point depression constant for different salts. Okay? So if you wanted to Google anything, you could Google what's the freezing point depression constant for sodium chloride. Okay? And it's probably going to give you a value in terms of so many degrees per mole, okay, that you put in there. And then that's how much is a mole of salt? Anybody, you do that? How many grams in a mole of salt? And NaCl, 58.5 grams per mole. Oh, we do, yeah, we do. Anyway, yeah, sodium's like 23.1 and chlorine's 35.5, so that's 15.5. And so, did anybody put more than 1 mole of salt in your ice? 58 grams? We don't even know. What's a tablespoon? How many grams in a tablespoon? That'd be nice to know. So did we put a whole mole of salt in there?
Does it make any difference on, you wanted to use crushed ice instead of the cubes?
Yeah.
Would that make a difference in you?
Well, you know, a nice thing to do on that, I've seen, if you take a block of ice and make a little cavity in it with a knife.
Okay, so that is a great question. But if we're going to teach the electromagnetic standards, there's a phenomenon, the question that you should be asking. If you do it with crushed ice and you do it with blocked ice, why does one work better than the other? And the crushed ice is clearly going to have a much lower temperature decrease. So why? Surface area.
Yeah.
But the kids have to get to that, right? The more surface area that the salt can come in contact with, the more it can have that temperature change, right? Anyway, every opportunity you get to ask a question or to bring out a phenomenon, you should be doing that.
Yeah. It's really a great thing. It goes much quicker with more
Yeah,
surface
so,
area.
I mean, I figured that's what
So a nice change of procedure on that is if you have an ice cube and you drill a little hole in it and put ice into the hole and put your temperature sensor into that place where it's a lot of salt with a little bit of the surface area, fun to watch. Something you could do at home. Yeah.
We were actually wondering if there is a maximum, minimum level that after a certain point, adding more salt doesn't make a difference.
I'm sure there is. There's limits to everything.
You know, how low can you take before even adding the
Yeah,
salt
I've
doesn't
seen
matter?
a negative 18 is the max I've seen doing this lab here. And I don't know if that's the minimum low. All right, we're going to go to the next step. We now have, it's a preliminary thing, right? And people have talked about making ice cream. This is what you put on the outside of the Ziploc bag that has your cream and sugar. And that's why it can freeze the milk with the sugar. You put some cherries in there or whatever, okay? And it's nice to do that as a fun lab, and then you can monitor one sensor in the milk and sugar, and then another sensor outside the bag with the salt ice. And don't confuse the two unless you really love to drink salt. But that's cool.
So in that case, do you have to be able to sterilize these?
Just put them under water. Yeah. I think there's as good as in a doctor's office with some isopropyl alcohol, rubbing alcohol, you could even do under your tongue, but I'm not asking you to do that. But physiology, I don't see anything really wrong with that, as long as you do sterilize it. Okay. Next lab, which really gets to be helps with the explanation of what's going on. And to do this, I want to predict what's going to happen first. So I'll explain the scenario, and then I want you to predict the shape of the graph. Okay? So we're going to take a test tube. Here they are. Okay. Here's my -10, -12 degree salt ice bath. Okay? And I have a test tube that I want to put in that much water. Okay? Now this water is pretty close to the temperature of the pipes. Okay? And here's the procedure. Take a temperature sensor. Hopefully this is the bottom of the test tube, like this. It's going to get plugged into your lab quest. So I'll know the initial condition of the water here. And then I'm going to take this system and put it into my salt ice bath, which is at -10 or colder. I want you to draw a graph, piece of paper, of what you think the temperature time graph looks like. And you probably need to do this for, I'm going to say 10 minutes, and if we need to append, we can. So think of a temperature on the vertical, time going out for 10 minutes, and at time 0, it's like this. After about 10 seconds, it's like this. And I want you to get average temperature, so it's a matter of stirring the sensor in the water of the test tube, and a little bit in here too. So dual action, you get average temperature. Draw your graphs. Yeah, piece of paper, you got paper there. Make a temperature time graph of the scenario that I've just described. Each person, yeah, we're going to do, actually, no, we don't have to do a final new because we're using one temperature sensor still. We're not changing to a force probe or something. But we will do, yeah, we can do final new because we want to throw away the data, right? If some of you really want to do two things, and you want to monitor the temperature inside the test tube and in the environment outside the test tube, you can put one there and the other one inside the test tube, and both plug into your lab quest. You'll have two graph lines going on simultaneously. There's plenty of temperature swings if you want to do that. And before we begin, I want you to show me your graph. Show me your predicted graph.
Somebody want some water? So 600 seconds is cool. And Richard's going to show you another way to show the prediction curve. You can do it on paper, or you can do it on your lab quest. So if you look up on the screen here, everybody look up here first before, and then we're going to have some movement. So Richard found this, and I was going to actually show it to you too, so I'm glad he did. So, yeah, let's listen to Richard. Analyze menu. So he's going to touch the analyze menu. And he's going to go to where, Rich? Draw prediction right here.
for this graph. And now we have a new graph screen. And is it taking a second? Right, here we go. He's using his cursor on the screen to draw the shape of the curve.
How did you get that? How did you get to this?
First analyze.
It was the analyze drop down and draw prediction. So Richard starts here, here's 0, here's 50, there's 10, 20, he's around 23 degrees interpreting this graph. And it went down to 0. And we got cold cookie zero. You do it again?
No, it's all right. You don't go below that.
Okay, so this graph is this is the temperature of the ice graph.
Yeah.
Yes. Oh, I'm sorry. So you say it's good enough. It's a 0 right? Okay, minus 1. So it never goes back. So it doesn't get as cold as the ice.
I would have gone down to the negative 100 zone as a quick line up there.
You have to go through the file. We haven't solved anything.
When it comes to the vertical load, so it starts to make sure you how to choose that landscape profile.
Can't get this one. Tentatively.
Did you get your initial water temperature for a little bit?
That curve is black, and that's just your curve. So now we're going to start building that. So we need our
606.
two temperature sensors.
How many seconds are we doing this one for? 600? So the tachometer is basically the dashboard.
So this is the lane slowly crawling. So as soon as this hits the airport, well stirred. Stirring gives you great graphs. Stir, stir, stir. Stir vibrate the sensor that's in the ice inside the test tube. Move it around. Because it's gonna freeze.
But it shouldn't get
Until after.
It's gonna freeze, and so
it's like boiling water when you get higher than 212. Boiling water below 212.
What's in the temperature should then?
The water's gonna freeze, yeah. Water
Once it's
resistance.
frozen in the test tube, then it might drop more.
No, because they got to zero it.
keep vibrating the sensor that's in the test tube. Just little short vibrations. We're actually going to super cool. important stirring and vibrating is the one that's in the test tube. Keep moving that around a little bit. The one in the test tube, keep it moving.
Yeah.
No, I mean, if I had to do that, I think the day before the lab, you get all the setup. So when they come in here, it's done. So there are break points where, as the teachers, we demonstrated how they had to set up their thing. On these things, you can actually have a file saved that is ready to go. Like you changed it to 600 seconds. And you can say this is not the we call it freezing temperature of water. So you can go live 14. So open up live 14. So you just set it up like that. But then it doesn't take long to change it to 600 seconds. So the whole idea
Our
is
biggest thing is, that's what you you're adopting that, have it ready for next year. Don't have to have 5
so you're
minutes.
going to have 20 minutes of data collection.
So if the salt has a
You're gonna miss that.
Well, it's obvious what you're going to have to do. And the day of intro on discussion, the day of data collection, and the follow-up. Good news, you only needed a sensor for 1 day. But you, as a teacher, you might want to teach some qualities that the teacher stations. That stuff, I'm with you.
Now, I always thought if you was a separation, to introduce the equipment, the state and ratio.
Which one is the blue? What does that water look like from the test?
Remember, ours was one of the higher ones.
So it's freezing because there's no salt. Two, cool. Pretty well done. We're
Your attention, eyes up here, please. Unbelievably nice. Okay, this I should pull this one up. Who'd go over to my computer for me right now? And this is CF number 2321A. Can you do that for me? Since I'm holding your test tube. Is this consolidated? This is so. Hit the upper left corner.
Yes.
Three minus squares?
Oh, yeah.
Squares.
I did.
Oh, it's not a touchpad. It's usually the touchpad.
Oh, sorry.
There you go. Thing is, now, touch. Do you find your pen in? Oh, just, there we go. All right. What's your name, please?
Joe?
Joe. I've got Joe's system right here, and she's displaying it up on the big screen. Joe, what's happening? Tell us what you've done so far.
Well, the first,
Walk up to the screen, please.
the very first thing that we did was we did the prediction, and this was really supposed to be like the room air, and then predicted that it was going to drop. This is what actually happened. I didn't think that it was going to take this long, that it would kind of level out, and it was going between, it was just above zero. It was 0.1 and 0.2 positive.
Really close
And
to
then
zero.
all of a sudden we moved something with a probe. Carol moved something with a probe and it dropped. Instantly just dropped. And it was because the water inside the test tube had completely frozen, and of course we had the slush on the outside, and we were moving it around still. So that's our graph.
Oh, would you right now push collect the green arrow? Oh, that's on my device here. Push the green arrow and say green. Okay. And with all the nice talk going on, we lost a few data points there. And we're looking at now, we took it out of the salt ice bath and just put their frozen test tube that has the frozen pure water in it. It's not distilled, but it's tap water. And there's the temperature. And we're now collecting it, temperature 1 degree at 782 seconds into the run here. So we're now doing the warming rather than just the freezing of the H2O that's in the test tube. Okay? And it's frozen in its lot. Actually, it can come out a little bit. Oh man. Okay, I'm gonna. This isn't embedded now. It's kind of come out, so I'm pushing it into the ice if I can, because I want the temperature of that frozen ice. And notice the temperature went back to zero, the freezing point. Okay. So I could accelerate the melting. What could I do to accelerate the melting if I wanted to?
Put it in warm water.
I could put some water in this. About 2 fingers, 3 fingers full. That's good. That's good. And I can accelerate that melting, and that's going to change the rate of change, right? Oh my gosh. The temperature sensor just slid down the side, right? Because it's melting that ice. And it's close to zero when it's melting. Then what's gonna happen? How long will it stay close to zero?
Until all the ice is gone.
Till all the ice is gone. So that's just really nice. Joe, you mentioned something that I hoped to avoid, but it's unbelievable that it's almost unavoidable. And then you said this temperature just plummeted, right?
Mhm.
So it was along here and you moved it, right?
Mhm.
And
Yes.
so you were really super cooled here.
Yes.
So if this is minus 10, 0, 10, 20, 30, that line looks very close to 0.
It was 0.01.
So you weren't so much super cool. Sometimes if you don't move the test tube in the ice, this does this. It comes down like this and then back up. You have a little blip below 0 and then it comes up back to here. And so that low blip is the supercooling. And yeah, it's beautiful to see. It's just one more level of, hey students, we're also studying supercooling today.
Can I ask another phenomenal question?
Sure.
What would you expect the temperature of the ice to be?
The ice will be 0.
Okay, so if the ice is 0 and that probe is in the ice, why did that temperature probe not say 0?
Oh, this right here?
Well, why does it change? Why did it come down below 0? Why was it above 0? Why were those things changing if you're measuring the temperature of the ice?
Because we had it in the salt water. When we were stirring it, it was in the test tube for the water, and the probe was inside the ice and salt water mixture.
Okay, is there salt inside the test tube?
No. But the slush that it was in was freezing the water inside the test tube.
Okay.
Right?
Well, because, well, with hers, what happened was, I guess hers froze like instantly because she used the probe to freeze. And now that it's all frozen, the temperature can drop again. Because now there's no liquid for them to take the
Okay.
energy to cause the freezing. Now the temperature can go lower.
That I agree. That is absolutely correct. So you had this 0 level where it's all freezing. Once it all
Right.
freezes, then it drops. That I agree with. That certainly that's a cooling temperature that you should see. I think every kid by the time they're in 8th grade ought to see this graph here, right? But now why is it 0? Why isn't it below 0? Now they're up here at ice. Why is it above the line there? So you got another issue there. What happened?
Is it local melting?
Now you're doing temperature.
Inside of that tube.